Okay, welcome to the next question of our shadow paper. So it says the equation x e to the x equals 2 can be written in the form f of x equals 0, where f of x equals x e to the x minus 2. Now, you would want to do this because the bit of maths that we're going to do is all about roots, okay? So writing something as a function equal to 0 is going to be a part of that. Now, the first step is quite standard. It says show that there is a root between this. Normally it wouldn't say exactly one root, okay? It would just say a root. So the idea is that we take the numbers of the question, or sometimes they give us a more specific number, and we evaluate the function. And what we're looking to do is a couple of things. So the first thing is we're just showing what that value is to quite a few decimal places. So let's do the first one. So 0.8 times e to the 0.8 minus 2. So I'm going to write, to kind of demonstrate this, I'm going to write that f of 0.8 equals, and I'm just going to write quite a lot of decimal places, okay? So minus 0.2196. Let's go for that. And then next, I'm looking to pick another value that's quite close to it and show that this causes there to be a change in sign. So if I do, well, that's just going to be 1, isn't it? So if I did e to the 1 minus 2, I will get a positive number, which is what I was looking for. So 0.7, let's do the same again. So 0.7183. And then I need a short conclusion here. So I need to say there's a change in sign and function is continuous. So you want to be saying change in sign, you want to be saying continuous. So there's a root between 0.8 and 1. Okay, so something like that. Show that the Newton-Raphson process is applied. So show that when the Newton-Raphson process is applied, it can be written as this. Okay, so Newton-Raphson process is not very different from this in the booklet. It says that the next approximation is equal to the one before minus the function evaluated at that value divided by the derivative evaluated at the same function. So what should we actually do here? Well, I suppose, first of all, we should just make it really obvious what the function is differentiated. So I'm going to go up here to do this one. So for b, I'm going to say if the function is equal to, what is it, x? Okay, so it's going to be a product rule, isn't it? So product rule, we're going to keep this. We're going to differentiate this bit. We're going to differentiate this. We're going to keep this. So it would be, so what did I say? So we're going to keep it and differentiate it and differentiate it and keep. So it's going to be that only. And then I saw that they had factorized something. So let's just make that nice and obvious. Okay. So, yeah. So, I'm just putting it in, but it's not really much of a show that experience on this one. Notice that all of the x's now have this notation, so that tells you sort of that we have to substitute these values in lots of places when we do that. So yes, I am just writing the same thing again because it is a show that question. So e x subscript n x n plus 1. And then I'll even put the left-hand side because they can be quite pedantic about this kind of thing sometimes. So the idea is now that we're meant to use this. So we're going to use 0.85, and it says to obtain it correct to 4 decimal places. So in this one, they don't want x1 and then x2 written out and so on. They just want you to do this enough until you get to the point where after a while it should stop changing. So the value should just stay whatever it is after a while. So what you would do here is you would evaluate. So I'm going to make this 0.85, and then I'm just going to have lots and lots of 0.85 in this question. Okay, so I'm not sure I'm going to actually do all of the steps, but I would write this down. So that's something that I definitely would do, just to make it obvious that I have the correct process. So I'm stating it and then I'm substituting it underneath. Yeah, okay, so I'll do that and I'll get my first value, and then afterwards I will change all of these to the ANS part, and I'm going to keep going until I've got something that does not change the first 4 decimal places. And explain briefly why it's correct. So this is going to be because it's going to converge. Okay, so I suppose I want to just explain that it converges rather than diverges, because the Newton-Raphson process won't always work depending on the values that are going into it. So we're just going to have a quick peek on this one. Where are we? So apparently we should get the values of 0.85 and it just goes up a little bit. So we're going to get our final value of 0.8526. Okay, and notice that this sort of fits the theme earlier in the question. So it's all about this one root that we seem to be concentrating on for this function.